In Lesson 3.7, our learning targets are just to be able to continue to do what we've been doing in class, and that is to be able to solve equations by factoring and then relate them to some real-world problems. And so in this first example, and you can follow along with these examples by opening up the Lesson 3.7 PowerPoint posted in Canvas. But in this first example, we're given a quadratic equation, and we are asked to identify what the solutions to this equation are. And so we're looking for the values of x that would result in us having an answer equal to 0. So if we think about the methods of factoring that we've learned to use to solve, the first step is always to look for a greatest common factor, and there is none. So the second step is to look and see if it's one of our special cases, like is it a difference of squares? Well, no, that's a binomial. This is a trinomial. Is it a difference of cubes or a sum of cubes? Again, no, those are binomials. This is a trinomial. So then we notice, therefore, that we'll have to go to the next step, which is just to either unfoil or group. But when the number in front of the x squared is a 1, then it's just really easy to unfoil. We know we're going to try to find two binomials that we can multiply together that'll equal 0, and that'll equal x squared minus 11x minus 12. So we know that first times first has to be x squared. So that's why we know these are both going to begin with an x, because x times x is x squared. Then we know that we need to find two numbers that multiplied together equal negative 12. Well, that means one of them has to be positive and one of them has to be negative, because that's the only way to multiply two numbers together and have it be negative. And when we add those two numbers, they have to add up to this middle term, which is negative 11, or middle coefficient. Well, when we think about the possible values of possible numbers that multiplied together can equal 12, they would be 1 and 12. Keep in mind, one of them has to be negative, 2 and 6, or 3 and 4. Well, the only way, if one of them is negative and the other is positive, for them to add up to negative 11 would be if we chose 1 and 12 and made the 12 negative. Because 1 times negative 12 is negative 12, and 1 plus negative 12 is negative 11. So therefore we know we're going to have one binomial that's an x plus 1, and the other binomial that's an x minus 12. And the x minus 12 equal to 0. And we solve. To solve this one on the left, we have to just subtract 1 from both sides. And we get x is equal to negative 1. To solve this one on the right, we'd have to add 12 to both sides of the equal sign. And we get x is equal to 12. Now to check them, we just go back up here to the original polynomial, and if I was checking negative 1, I'd plug the negative 1 in for x and see if when we do so, I don't know what I did there, we'd have negative 1 quantity squared minus 11 times negative 1 minus 12. And we want to see if that equals 0. Well, negative 1 squared is 1. Negative 11 times negative 1 is 11, so 1 and 11 add up to 12, and 12 minus 12 is 0. So the negative 1 works. We can also go back and we can check to be sure that the other solution works, which was 12. Well, 12 squared is 144, and then we have to multiply before subtracting, so 11 times 12 is 132. 144 minus 132 is 12, and 12 minus 12 is 0. So they both work. Our solutions are negative 1 and positive 12.